Okay, so here we go. We're going to take care of, I'm going to do one with, all right, so I'm going to do number 4 with you. You're going to do 5 and 6. All right, so do we have to treat this as a limit? Yes, why? Because if it's either undefined somewhere, is it ever undefined between 1 and infinity? Psst. Is it ever undefined between 1 and infinity? No, but it is really, the question is, what is its value at infinity? So we're going to write this as the limit as b goes to where? Infinity, bless you. And how should I probably rewrite that? X to the what? Negative third dx, okay? And we're going to integrate that from 1 to some number b, right? Okay, so what is the antiderivative of x to the negative third is what? X to the negative second, and what goes out front? Negative 1/2. I still am going to have my limit in front, and that's going to go from 1 to b. So let's rewrite this into something that I can deal with a little bit better. So as b goes to infinity, okay, I'm going to take that negative 1/2 and put it out front, okay? So this is really in the bottom, it's going to be what? B squared, does that make sense? So I'm going to write that as 1 over b squared minus, what is that? 1 over 1 squared, okay? I'm just making sure all my numbers are right. Yes, they are. So I get negative 1/2. As b goes to infinity, what does this term become? 0. What does this become? 1. So I make sure that that's 0 minus 1. So what is that area equal to? Careful. Negative 1/2 or positive 1/2? Positive 1/2. Okay? So this one was 1. This is 1/2. Well, I have a question for you. 1 over x squared is here. Where is 1 over x cubed? Would that graph be above that one or below it? Below it. So what should be happening as this exponent gets bigger, this area should be getting what? Smaller. Okay? So I want you to go do number 5, and then we'll do 6 together. Okay? Bless you. Okay. So if I went ahead and did this, if you look at it, so that became x to the negative third, and then what came out front? Negative 1 what? Third. From 1 to b. So now when I plugged in, I pulled the negative 1/3 out front. So this becomes b cubed in the bottom. This becomes 1 over 1 cubed there. So what is this? What does this become? The 1 over b cubed is what? 0. So don't I get 1/3 times 0 minus 1, I'm sorry, negative 1/3. What does that equal? 1/3. Is that getting smaller? Okay. Have you figured out the pattern yet? Yeah. What's the pattern?
1 minus the exponent.
Yes. Now, so in general, we could say that 1 over x to the p from 1 to infinity, what does that equal in general? It's 1 over, how would you write that? P minus 1. But I want to point this out, that only is true when the limits are what? 1 to infinity. If I change this to a 2, you'd still have to do it, right? Okay, so can you tell me what is this going to equal? P is what number? P is 10, so what's the area going to equal? Is 1 over what? 10 minus 1, which is 1 what? 9. Does that make sense? Okay. The minute I change that limit, it changes. Okay. So let's look at number 7. Are those the same limits? No. But I want you to think about this. Here's 1 over x. We are now trying to find the area from where to where? From 0 to 1. So we're trying to find it in there. And this goes up to a vertical asymptote. So it may have a finite area, or it may what? Not. Where is the problem? Is it at 1? Is it at 0? Or somewhere in between? Somewhere in between. All right. So no, it's going to be at where? 0. I'm sorry. So it's the limit as b goes to 0. It's not always the top end point. It could be the what? The bottom. Okay? So I'm going to do 1 over x dx, and then it's from b to 1. Okay, so what is, okay, I make sure I write the word limit very clearly. All right, what is the antiderivative of 1 over x? Is it negative 1 over x squared, or is it the natural log of x? It's the natural log of the absolute value of x. And now we got to go from b to 1. B goes to 0, thank you. Thank you, I'll just... Okay, you know what I have to write for that? I'm going to draw you a little picture. You know what that means? I showed you that before, didn't I? That means this is you, this is me, you got my what? Yeah, I'm back. Okay. All right. I wanted to make sure our audience at home saw that too. Okay. So I get the limit as b goes to 0. I know some of you are still trying to figure that one out. I know. All right. So don't I get the natural log of 1 minus the natural log of b? Okay. Got to remind you, what is the natural log? What is the log any base? All right. That's the word limit. It doesn't matter if this is log base 20 of 1. Doesn't matter if it's natural log of 1. That is always what? 0. Okay. Natural log function, if you remember, looks like this. As you approach b, and by the way, we are going from which side? Do you remember? I didn't write it there. Aren't we really looking at it from the right? Should have done that. What is that approaching? What number is that approaching? Negative infinity. So what does this? So it's negative infinity, but it's the opposite of that. So it's what? Positive infinity. So is that a finite area or an infinite area? Infinite. So what's our word that we write? It diverges. And just a reminder, what did all of these up here do? They all converged. They came to a fixed value. Okay. Next one we're going to do is number 8. How do you look at what we're doing in the back, because there are a couple of these I'm going to have you do. Some of these are a little bit nasty, but we need to do them because they're ones that we have to make sure that we do. So let's look at number 8. So first of all, what does e to the negative x look like? I want you to look at the graph.
1 over e to the x.
Okay, or it's 1 over e to the x, but if it were e to the x, that would be exponential what? Growth. This is actually exponential what? Decay. So it's going to start here, and it's going to this. Now, eventually, are we adding 0? Eventually, are we adding 0 out here? Yeah. So could it possibly be a whole number answer or a finite number? Yes. Is it necessarily? No. Because, okay, so let's look at this. So where are we worried about? Is it at 0 or is it at infinity? Or somewhere in between? It's at where? It's at infinity, so I'm going to do the limit as b goes to infinity of e to the negative x dx, and that's from 0 to b. Okay, what is the antiderivative of e to the negative x? Well, I know it's e to the negative x, but what has to be in front? Negative, right? Okay, so I get the limit as b goes to infinity of that, but I still need to evaluate it from 0 to what? To b. Okay, so I get the limit as b goes to infinity of, and let's be really careful, negative e to the negative b plus, why is it plus? It's negative, e to the 0 power. Okay, would it be easier if we put this on the bottom? Well, let's think about this. As b goes to infinity, what is this really? This is e to the what? Negative infinity? What is e to the negative infinity equal to? That's 0. Okay, that is 0. Or if you want to write it as negative e to the b, if that's easier for you, that the bottom is really growing fast, and that essentially becomes what? 0. What is e to the 0? 1. So what is the area? It's 1. So we would say it what? verges. So there we have a new definition of 1. It's the area under that curve equals 1. Not that you'd ever use that as your definition of somebody that it equals 1, correct? But it does equal 1. All right, so we're going to skip ahead a little bit because I want you to go do a couple on your own. I want you to go do on the next page, I want you to go do number 12, which I will tell you, my hint is, could you rewrite it like we did last time? X to the 11th and x to the 13th. And then I want you to go do, so I want you to do 12, 13, and what? 14. Okay? Oh, I want you to go do 10 also. Why don't you work with a partner, though? Take a few minutes. I want you to do those 4. So 12, so 10, 12, 13, and 14. Okay?
Mr. Jones,
Yes.